Hi everyone, I am Mrs.P.HAMEETHA Begum, Assistant Professor of Mathematics, A.D.M. College for Women, NAGAPATTINAM. Today I am going to discuss about the last section of the subject Vector Calculus and Fourier Series. So as a continuation of the third module, here we are going to see the topic operators involving del twice. So for a given scalar point function phi and a vector point function f vector, there are 6 possibilities using del twice. They are, first one, del dot del phi, that is divergence of grade phi. Divergence of grade phi. We already know that del phi means gradient of phi. And the second possibility is del cross del phi, that means curl of gradient phi. So cross product mentions the curl product. So next one, del dot del of f vector, that means del square of f vector. The fourth possibility is del dot del cross f vector, that is divergence of curl f. Divergence of curl f vector. And the fifth one is gradient of del dot f, that is gradient of div f. Gradient of div f. And the last one is del cross f vector, that is curl of curl f vector. So now we are going to find the values of these 6 possibilities, explanations of these 6 possibilities. First one, del dot del phi, that is, we know that del means dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector. Now dot product, and del phi is dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector. Now if we find the dot product, we get this as dou square phi by dou x square. As in the dot product, we get I dot I 1, j dot j as 1 and k dot j as 1, and dot producting I and j and I and k, we get 0. So we have to just multiply the coefficients of I vector and j vector and k vector correspondingly in the dot product. Therefore, we get dou square phi by dou x square as the first term, dou square phi by dou y square as the second term, dou square phi by dou z square as the third term. Shortly, we can tell this as del square of phi. And this expression is called as Laplacian of phi. Laplacian of phi. So the first possibility we have explained. Next, let us go to the second subdivision, that is del cross del phi. Now first we have to calculate del phi, that is gradient of phi, and then we have to find the curl of that gradient phi. So gradient phi means, already we wrote in the previous step, no issue. Now also I am writing this dou by dou x, that is del phi is equal to plus dou phi by dou z k vector. Now we can calculate del cross del phi. So now dot product we do just like this, but cross product we have to put the determinant and we have to expand the determinant value. So 3 cross 3 matrix format we have to write. First row we have to write I vector, j vector and k vector, the directions, and in the second row we have to write the coefficients of the del, that is the vector differential operator, that is dou by dou x, dou by dou y and dou by dou z. And in the third row we have to write the coefficients of del phi, that is gradient phi, that are dou phi by dou x, dou phi by dou y and dou phi by dou z. And expanding this determinant, it's first row we get I vector. So we get dou square phi by dou y dou z minus dou square phi by dou y dou z. Next, minus j vector, we have dou square phi by dou x dou z minus dou square phi by dou x dou z. And the last term, k vector, dou square phi by dou x dou y minus dou square phi by dou y dou x. Now, the first term, the coefficient of I vector is dou square phi by dou y dou z minus dou square phi by dou y dou z. Those two terms are similar with a minus in the middle. Therefore, they get cancelled and the coefficient of I becomes 0. Similarly, j vector, the coefficient becomes 0 and k vector, the coefficient becomes 0. Therefore, this is equal to 0. So, this possibility, that is curl of gradient phi becomes 0. Next, third subdivision. Now, let us see the third subdivision, del dot del f vector. It's nothing but del dot del means del square of f vector. So, we get dou square f vector divided by dou x square plus dou square f vector divided by dou y square and dou square f vector divided by dou z square. So, that is the third subdivision. And the fourth subdivision, del dot del cross f vector, that is divergence of curl f. So, first we have to find del cross f. So, let us find del cross f vector, keeping the determinant 3 cross 3 matrix I, j, k, and in the second row we have to write the coefficient of del, dou by dou x, dou by dou y and dou by dou z. And finally, f vector. F vector is the constant vector. Therefore, we can write the coefficients as f1, f2 and f3. Now, expanding the determinant value, we get I vector into dou f3 divided by dou y minus dou f2 divided by dou z minus vector dou f3 divided by dou x minus dou f1 divided by dou z. And lastly, k vector, coefficient of k vector as dou f2 divided by dou x minus dou f1 divided by dou y. And now, let us find the dot product, divergence of this del cross f. Therefore, divergence of del cross f vector as del is nothing, dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector. And we have to dot product this with del cross f, these values. So, I vector dou f3 divided by dou y minus dou f2 divided by dou z and minus j vector dou f3 divided by dou x minus dou f1 divided by dou z plus k vector dou f2 divided by dou x minus dou f1 divided by dou y. Now, taking the dot product, we get the values dou square f3 like that. But if the values of f1, f2, f3 are given, we can find the differentiation of f3 twice with respect to x, or y or z, whatever it may be. So, the answer will be just a scalar value. As the dot product, we get dou by dou x of dou F3 divided by dou Y minus dou F2 divided by dou Z. And J vector, we have minus J vector, minus, we get dou by dou Y of dou F3 by dou X minus dou F1 by dou Z. And finally, K dot K becomes 1 and dou by dou Z of dou F2 by dou X minus dou F1 by dou Y. So, the answer will be a scalar. Okay, that's all. The fourth subdivision. Now, let us see the fifth subdivision, del of del dot F. The fifth subdivision, del of del dot F vector. So, first we have to know del dot F vector. Now, find that. So, del means dou by dou X I vector plus dou by dou Y J vector plus dou by dou Z K vector dot F vector is a constant vector. Let us take that as F1I plus F2J plus F3 K vector. Now, having the dot product, we get dou F1 by dou X plus dou F2 by dou Y and dou F3 divided by dou Z. Now, we have to find the gradient of this divergence F. Now, del of del dot F vector is equal to dou by dou X I vector plus dou by dou Y J vector plus dou by dou Z K vector of this dou F1 by dou X plus dou F2 divided by dou Y plus dou F3 divided by dou Z. We have to find in the next step, we have to differentiate this F vector, these values with respect to X and with respect to Y and with respect to Z, and finally we get the value as a simply as a vector, as the values F1, F2, F3 are not given. We cannot find the next steps. If the values are given, we can proceed the problem. Now, the sixth subdivision, del cross F vector. Del cross F vector, that is curl F vector. As usual, first we have to find del cross F vector. Del cross F vector have the determinant as 3 cross 3 matrix I, J, K, dou by dou X, dou by dou Y and dou by dou Z. And the third row, the coefficients of F vector is F1, F2 and F3. So, expanding the determinant, we get I vector dou F3 divided by dou Y minus dou F2 divided by dou Z minus J vector dou F3 divided by dou X minus dou F1 divided by dou Z, and the third term K vector as dou F2 by dou X minus dou F1 by dou Y. So, we have calculate del cross F vector, and the next step is we have to find the curl of this curl F vector. Del cross F vector is, again we are going to find the curl only. Therefore, one more determinant we have to frame as such I vector, J and K. Now, in the second row we can write dou by the coefficients of del, dou by dou X, dou by dou Y and dou by dou Z, and the coefficients of del cross F vector, just we have found that value. The coefficients of I is dou F3 divided by dou Y minus dou F2 divided by dou Z, and the coefficient of J vector is bring this minus inside, then we get dou F1 by dou Z minus dou F3 divided by dou X, and the coefficient of K vector is dou F2 divided by dou X minus dou F1 by dou Y. Now we have to expand this determinant again. So I vector, we have dou by dou y of dou f2 by dou x minus dou f1 by dou y, this value, cross multiplying these two values, and dou by dou z of dou f1 by dou z minus dou f3 by dou x. So this is the coefficient of I vector. Again minus j vector. Now writing the coefficient of j vector, we get dou by dou x of dou f2 by dou x minus dou f1 by dou y minus, that is cross multiplying these two values and subtracting these. So dou by dou z of dou f3 by dou y minus dou f2 by dou z, and finally the coefficient of k vector as plus k vector, and cross multiplying these two values, dou by dou x of dou f1 divided by dou z minus dou f3 divided by dou x minus dou by dou y of dou f3 by dou y minus dou f2 by dou z. By all these terms. As the expression is very big, we can calculate we can proceed the next steps for the I vector, and then with the summation, can proceed this with summation. That is, summation means it represents the sum of all these terms with the representation of coefficient of I vector alone. Now summation I vector. Now the coefficients are dou square f2 divided by dou y dou x minus dou square f1 divided by dou y square, again minus dou square f1 divided by dou z, minus of minus plus, we get dou square f3 divided by dou x dou z. Okay. So as we have used summation, we can neglect the coefficients of j vector and k vector. And here there are 4 terms, and looking into these 2 terms, we have both are negative terms, and dou square f1 are in the numerators, and with y square we have to differentiate with respect to y twice in this term, with respect to z in this term, and one is missing. Which one? Dou square f1 divided by dou x square term is missing. And also considering these 2 terms, we have dou square f2 and here dou square f3. In the denominator, f2 means it represents dou y dou x, and here dou x dou z. So we need one more term in dou square f1 with respect to x twice, differentiating x with respect to twice. Therefore, we have to add and subtract the term dou square f1 divided by dou x square. Add and subtract in the coefficient of I vector. Then we get summation I vector. Now adding the first, add the value, positive value in the first term as a first term. So dou square f1 by dou x square plus we can take the positive terms in the starting part. So dou square f2 divided by dou y dou x and dou square f3 divided by dou x dou z. And now adding the negative part of dou square f1 by dou x square, we get dou square f1 by dou x square. Again writing the negative terms, minus dou square f1 divided by dou y square minus dou square f1 divided by dou z square. So now we get 6 terms, and we can rewrite these 6 terms as follows. So which is equal to summation I vector. We can write these 3 terms, the positive terms, as dou by. We can take dou by dou x in common for the first 3 terms. Therefore, we can write this as dou by dou x of dou f1 by dou x plus dou f2 divided by dou y and plus dou f3 divided by dou z. So in the first three terms we have taken the value dou by dou x in common and remaining write the remaining terms in the bracket, and again concentrating on the last three terms we can take minus as a common and we can write this as del square f1, the del square f vector with reference to the section subdivision 3. Now dou square f1 by dou x square plus dou square f2 divided by dou y square plus dou square f3 by dou z square. So in the next step we can write this as summation I vector dou by dou x of, this value is nothing but del dot f vector, since del dot f vector we get dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector dot f1i plus f2j plus f3 k vector, and dot having the dot product we get dou f1 by dou x plus dou f2 divided by dou y plus dou f3 divided by dou z. Now therefore we can replace this bracket term into del dot f. Now again this value is nothing, from this section 3 we get del square of f vector. Okay, so now getting the summation into each and every term and expanding with all the terms, that is j vector, k vector, all the terms, we get this term as I dou by dou x plus j vector dou by dou y plus k vector dou by dou z of del dot f vector minus del square f vector, and simply we can write this as, this is nothing but the vector differential operator del, therefore del of del dot f vector minus del square f vector, hence curl of curl f is nothing but del of del dot f vector minus del square f vector. Thank you.